Hey, welcome back. This video is really a part 2 to my original video, similar figures. So here I'm going to be doing a couple of examples coming up. Okay, Jason is drawing a scale diagram of his bedroom, which is a rectangle 5.2 meters long by 4.6 meters wide. On his diagram, he draws his room 8 centimeters long. A. How wide will his bedroom be on the diagram? And B. What is the scale factor for the diagram? The original room is the object, and the diagram that Jason is going to draw is the image. If we label this A, B, C, D, and the diagram A dash, B dash, C dash, D dash, then we can set up some corresponding sides. So the first side that I'm going to set up is A dash, B dash over AB. That's this side here, the length by the original length of the room. I know that the image is 8 centimeters because it tells me on the diagram he draws his room 8 centimeters long. And the original room is 5.2 meters in length. Now I have to either convert centimeters to meters or meters to centimeters, and I'm going to do the latter. So I've got 8 centimeters over 520 centimeters, and I can simplify that to 1 over 65. Now if these two rectangles are similar, then they have to have the same length ratio. We know that the length ratio between the object and the image is 1 over 65. So that should be true for this corresponding length as well. So A dash D dash over AD. Now I don't know what A dash D dash is, but I do know that the width of the room is 4.6 meters. Like before, I'm going to convert that to centimeters so we have the same units of measure. And I do know that that should equal a length ratio of 1 to 65, provided that the object and the image are similar. So I can set this up and I can say A dash D dash is equal to 1 over 65 times the 460. So if I use an inverse operation, because that's divided by 460, I can multiply it here. So basically I'm taking this and I'm multiplying it on this side. That gives me 1 over 65 times 460. So to one decimal place, A dash D dash is 7.1 centimeters. And that answers the questions. How wide is the bedroom on the diagram? 7.1 centimeters wide. So part B, what is the scale factor of the diagram? Well, you may have noticed it already. The scale factor is k equals 1 over 65. You may have noticed that from the original part of the question that we worked out, 1 over 65. Okay, so you may want to pause the video here and make a couple of notes in your book. Right, we're going to move on to a more tricky question. This is more of an advanced question. A picture x centimeters by y centimeters is surrounded by a frame z centimeters wide, as illustrated. So here. Prove that the rectangles in the figure are similar only if the picture is a square. Right, so let's start labeling our diagram. My picture, which is the object, I'm going to label it as A, B, C, D, and then the image, which is the frame, A dash, B dash, C dash, and D dash. Right, so in any case, whether this is a square or a rectangle, I know for the shapes to be similar, they have to have the same side length ratio. So A dash, B dash over AB must be equal to B dash C dash over BC, and so on and so forth. So C dash D dash over CD, and then A dash D dash over AD. All of these, if they're similar, have to have the same side length ratio. Pause the video here and attempt to solve this question on your own. So if the picture and frame were rectangles, the length would be represented as A dash B dash over AB. So we're looking at this first set of corresponding sides. Because my frame has a width of Z centimeters, that's true on this side as well. So imagine that I've got Z over here. Of course, this is Y, and then I've got another Z over here. Hence, I've got Y plus 2Z over Y, because AB has a length of Y. Now the width of the shapes is represented by b dash c dash over bc. So again, b dash c dash is going to be x plus z over here and another z over here, because remember this and this is z or z centimeters wide. So that's going to be x plus 2z over x. Now you may notice, because these variables are different, we've got y over here and x over here, the shapes are not similar. Okay? Now if the picture and frame were squares, the key piece of information that we know, because it's a square, the length and width are going to be equal. So therefore we can say that the length can be written as x plus 2z over x, and the width can be written as x plus 2z over x. Because x and y are equal, this would hold true. So the two shapes would be similar. As always, thanks for watching. If you found the video helpful, drop me a like and comment, and if you haven't already, consider subscribing. I'll see you in the next one.